Hi everyone, welcome back to the channel. In this particular video, I will be explaining problem A, B and C of Codeforces round 947. Okay, so let's start with problem A, and first of all we will try to understand the problem statement, then we will see how we can solve this. So problem statement is very simple. What they are saying is we have been given an array of size n. Okay, let's suppose this is the array of size n, and we have to perform some operations. And what the operation is we have to choose a prefix of the given array, and we have to choose a suffix of the given array. Okay, let's suppose for now I'm calling the prefix as x and suffix as y, and we have to choose prefix and suffixes in such a manner that by the concatenation of both the original array should be formed. Okay, A. Now what we can do is we can swap these two parts, okay, prefixes and suffixes in their respective positions, and we don't have liberty to change the elements in the chosen prefix or in chosen suffix. Let's take an example and try to understand with that. Example is 79223. Okay, 79223, 79222 and 3. And what is our goal? First of all, let's discuss that also. And what is our goal? Our goal is they are saying that after performing this operation some number of times, there is no limit on the number of operations. So after performing this operation some number of times, whether it is possible or not to sort the array, this is the final thing that they are asking. For example, this is the test case that has been given in the problem statement. Now let's try to choose a prefix and suffix in such a manner that after altering that we can have a sorted array. What we can choose here, let's suppose for now I'm calling this as prefix and this as suffix. Okay, this part is x, this part is y. What we can do is we can't change the order of elements in x and y itself, but the thing that we can do is we can swap x and y. Okay, so we can swap x and y, and then the order will become 2, 2 and 3 and 7 and 9. Okay, so now as you can see here that x and y are swapped. Okay, now this one is y and this one is x. Okay, and here after performing the operation only single number of time, we are having a sorted array. Then we can say that okay, yes, it is possible to perform operation some number of times in order to get a sorted array. Fine. I hope the problem statement is clear to everyone. Now let's talk about how we can solve this. Approach is very simple, guys. First of all, what we can do, approach is very simple, guys. First of all, what we will do is we will break the array into some chunks. And before that, let me mention one thing, that it might be possible to solve this problem in a single line or single iteration. Okay, but the way I have done it during the contest, I'm explaining that only. Okay, and I hope you will be learning something from my approach. Okay, so what I have done is I have made the chunks of the given array such that each part is sorted individually. Okay, each part is sorted individually. Like as you can see here, the given example was 79223. Okay, so 7 and 9 is sorted in itself. 2 to 3 is also sorted. So I have breaked the array into two chunks in which all the elements in each particular segment is sorted. Fine. And now my claim here is if the chunks in which I'm dividing my given array is greater than 2, then answer will never be possible. Why so? Let me explain that. For example, let's suppose this one was the first chunk. Okay, 1, 2 and 3 was here. Okay, and for the next segment to be divided from this particular segment, the element should be smaller than this element. Okay, the next segment element should be smaller than this element, because if the element is greater than this, let's suppose 4, then this will be merged with this particular segment. So we know for sure that this element means the starting element of the second segment is going to be lesser than the ending of the first segment, last element of the first segment, you can say. So for example, let's suppose this element is 2, fine, and 6 and 7. This one is a second segment. Now let's suppose we are having a third segment in which we know for sure that this particular element is going to be smaller than this, because if it is greater than or equals to this element, then that particular element will be merged with this particular segment. Okay, so we know that this element is going to be less than the last element of the second segment. Okay, so for example, let's suppose this one is 5, now 7 and 9. This is sorted in itself. Now what we can say is answer will never be possible in this particular case, because no matter how many times you perform the operation, you have to choose a prefix and suffix. So let's suppose I have to choose this particular element, this particular segment as prefix, and I can choose this as suffix, because these are not sorted completely. Okay, so you have to choose these two elements, these two segments, and if you swap these two, but as you can see here that even after the swapping, we will never be ending up having a sorted array, because 5 7 9 will be placed in front of this 5 7 and 9. But now these elements are becoming less than the element which is having end of the first segment, which we are placing at the first place. So eventually we will be ending up having a non-sorted array no matter how many times you perform the operation, if the sorted segments are greater than 2. But if we are having only two segments, then answer is always possible. Okay, answer is always possible. If you are having only two chunks which are sorted in itself, then answer is always possible. Or for safety, what you can do is you can place x and y. Let's suppose these are the two chunks which are sorted in their particular places. Then what you can do is, for checking, first of all place x and y, then place y and x, and check that whether this configuration is sorted or not, or this configuration is sorted or not. Any one of these will always be sorted. Okay, if we are having some segments which are, so if I try to summarize this, so now if I try to summarize the solution, what the solution is, first of all we have break the array into some parts, some segments which are sorted. Okay, this part is sorted, this part is sorted, and I'm saying that if the number of segments that are sorted in itself is greater than 2, then answer will never be possible. And if sorted segments are 2 or 1, means less than 2, basically less than equals to 2, then answer will always be possible. Okay, so yeah, this was all about problem A. Problem A was very simple. Now let's move on to problem B. What problem B says, Mocha likes an array. Mocha like arrays. Okay, so before her departure, this particular person gave her an array A consisting of n positive integers as a gift, and Mocha thinks that A is beautiful if there exist two numbers I and j such that for all elements, for all k between 1 to n, AK is divisible by either of AI and AJ. What they're saying basically is, let me explain it. First of all, they have been given an array. Okay, let me explain it here. First of all, they have been given an array of size n. Okay, size of array of size n. Now they are saying us, now they want us to choose two elements out of all the possible elements in the given array. We have to choose any two elements. Let's suppose for now I'm choosing this particular element as I, index as I, and this particular element as j. Okay, so out of all the n elements, we have to choose any two elements, and the condition that needed to be satisfied is each element, for example this element, this element, this, means all elements should be divisible by either one of them. Okay, means let's suppose 2 was here and 3 was here, so we have chosen two elements, 2 and 3. Now the only condition that is needed to be satisfied is this particular element should be divisible by either 2 or 3. This element should be divisible by either 2 or 3. And similarly for this and this, we have to check for all n elements. So they are asking that, is it possible to choose any two elements out of all given n elements such that each element is divisible by either of 2? I hope problem statement is clear to everyone. Now let's talk about how we can solve this. Problem is very simple, guys. See, first of all, what we will do is we will sort the given array. And why we are sorting the given array? Are you able to figure out this? Why we are sorting the given array? First of all, we will sort the original array. We are sorting because after sorting we know that this one is the minimum element. Okay, this one is the minimum element. Let's suppose this particular thing is x here. I am calling this as x. Let me write it in a clear manner. Let's suppose the first element, that is the minimum one, is x, and what we want to choose two elements, y and z. Okay, so let's suppose x mod y should be equals to 0, or the out of these two conditions only one is needed to be satisfied. Not one necessarily, both can be satisfied simultaneously. There will be no problem. So what they are saying is the first element, that is minimum one, is x. Okay, and the two elements that we have selected are y and z. Now tell me one thing. If this condition is satisfied, what we can say about y? Y should be less than or equals to x. Don't you think so? Y should always be less than or equals to x, because if y is greater than x, then we can't get remainder as 0. We will get remainder as x. So y should be less than or equals to x. Similarly here, z should be less than or equals to x. So we know that x is the minimum element, and in order to have an element that divides x completely, we need the element that is less than equals to x. But we know that the smaller element is x, and we don't have any element in our given array that is smaller than equals to x. Okay, so for sure I can say that this is going to be our first element that out of those two which we have to choose. Okay, array of 0 is going to be my first element out of two which I have to choose. Okay, so the second thing that is remaining is we have to find the second element. Fine. In order to find the second element, let's try to have some observation. Can I say that if this is my first element, then I can check how many elements are divisible by x, means the first element. And if all elements are divisible by x, then I can say that okay, answer will always be yes, because the first element is x, means array of 0, and second element can be anything out of n minus 1 elements, because all the elements are divisible by this particular element. So we can say that okay, answer is always possible. But if let's suppose we are having some elements which are not divisible by x, let's suppose this is the element that is not divisible by x, this one is not divisible, this one is not divisible. So at the end of the day, we are having 3 elements which are not divisible by my first element that I have chosen. So here is the array that is storing all the elements which are not divisible by the first element. Okay, now the same thing you have to do on this particular array. You have to sort this array. Okay, you have to choose next element, means the second element, as the starting, means the minimum element of all the elements which are not divisible by x. I hope it makes sense and it is clear what I'm doing. Let me explain it again. What I'm doing is we have to choose 2 elements so that all the elements individually are divisible by either one of them. Okay, so what I'm saying is the first element is definitely going to be the minimum element of the array. Okay, for that reason we have sorted the array and we have chosen the minimum element as first one out of both. Okay, now I'm saying that all the elements of the given array which are divisible by x, they are not causing any problem to me. The only problem that can occur is all the elements which are not divisible by this particular element. So what I have done is I have stored these elements which are not divisible by x in a separate array, and I have done the same thing on this particular array. So these are the elements which are not divisible by x, and we have sorted this array, and after sorting we have chosen this element as the second one. And after choosing the second element, we have to check for all the elements which are remaining that whether all the elements are divisible by this element or not. If no, then answer is always going to be no, because if some elements are still remaining which are not divisible by the second element which we have chosen, then we have to then again perform the same operation. As you can see that this is converting into a given sub problem. Okay, so if I try to ask an extended version of this particular problem, then you can say that what are the minimum number of elements that are required so that each element is divisible by any one of them. So you have to perform a simple recursion here, because as you can see that a greater problem is breaking into a simpler sub problems. Okay, so coming back to the problem statement. Okay, what we have done is we have first of all chosen the minimum element of the array as first element, and all the elements which are not divisible by the minimum element, we have stored those elements in the separate array. And the same thing we have done here. Again we have sorted the given remaining elements, and we have checked that all the remaining elements are divisible by the second element or not. If this is the case, then answer is always yes, otherwise no. Okay, you can see the code here, but what you can do is first of all, what can be a simpler implementation? Simpler implementation can be sort the given array and choose the first as the first element, and iterate over all the elements and maintain a temporary vector in which store all the elements which are not divisible by this element. Okay, and perform the same thing on this particular array. And if any element is still remaining in this particular array which is not divisible by the minimum element of this array, then answer is no. And if all elements are divisible by the minimum element of this array, then answer is going to be yes. So yeah, this was all about problem B, guys. Now let's move on to problem C. Problem C is also very easy. Problem C is easy, just a simpler observation that we have to make here. What is that? Let's talk about that. First of all, let's try to understand the problem statement. Mocha likes arrays. So before her departure, Chamo gave her an array A consisting of n integers as a gift. Fine. Mocha doesn't like arrays containing different numbers, so Mocha decided to use a magic change in the array. Mocha can perform the following 3 steps of operation, okay, possibly 0 number of times. So what problem statement is saying is, we have been given an array, okay, we have been given an array of n integers. and our goal is to make all the elements equal. Okay, all the elements equal, and let's suppose all the elements are x x. Okay, all the elements are x x, and the value that will be having as x should be maximized. Okay, and now let's talk about what are the operations that we can perform on the given array in order to make all the elements equal. Operation is choose any two indices L and R. Basically, we have to choose a sub array. For example, this is the given array. We have to choose any two left and right indices. Basically, we have to choose a sub array. Okay, and we have to replace all the elements in the chosen sub array with median of this particular sub array. Okay, and now what is the median? Median is the mid element after sorting all the elements. For example, 1 1 2 4 6. So still this is sorted, but if let's suppose 7 was also here, so after sorting 7 will become here, will placed here. So after sorting the given numbers, whatever is appearing in the mid is considered as median. Okay, and we have to take the ceil value, not the floor value. And we have to take the floor value, means the previous element. For example, let's suppose there were 5 elements and mid one was 5 by 2, that is second element. Fine. Okay, I hope the median concept is clear and the problem statement is also clear. Operation is we can choose a subarray and we can replace all the elements of the chosen subarray with the median of that particular subarray. And after doing this, we have to perform the operations until we are having all the elements in the given array equal to each other. And the elements which are equal to each other is, let's suppose that this is x. Now the value of x should be maximum possible. That this is the problem statement. Now let's talk about how we can solve this. There are some observations here which I will try to make. What is the first observation? Let's suppose I'm saying that this is my given array. Okay, this is my given array. Can I say, let's suppose this is A, first element is A, B, C, W, X, Y, and Z. These are the elements of my given array. Okay. Now can I say guys, if I choose 3 elements, okay, if I choose 3 elements, then I can make the complete array equals to the element which is at the mid position, and ABC should be in sorted order. Okay, let's suppose first of all I have chosen ABC, the first element, first 3 pairs, not pairs, first 3 triplet. Okay, A, B, and C, and now I have written the ABC in the sorted manner. Now can I say that I can make all the elements equal to B? Can I say that? Yes, I can say, because first of all what I will do, I will choose these elements, and this one is the median, B is the median, so I will make A equals to B because B is the median. Now C equals to B. Okay, after this what I will do, I will choose these 3 elements, okay, and now B is going to be the median. Fine, because B is appearing 2 times out of 3, so B will always be in the mid, so B is going to be the median. So eventually W will be also be converted to B. Now choose the next 3 elements, so on and so forth. We will be ending up having all the elements equals to B. Okay, and what is the next thing? Can I say that if I choose X, Y, and Z, these 3 triplets, now let's suppose I'm choosing these 3 numbers X, Y, and Z. Now can I say that I can make all elements equal to Y? Yes, I can, because X, Y, Z, whatever is the median of X, Y, and Z. First of all, what we will do? First of all, we will place X, Y, Z in sorted order. Okay, and now let's suppose Y is the median. So can I say that I can make all the elements equals to Y? How? First of all, I will choose these 3 elements, so all will be becoming Y, because Y is the median. All will be converted to Y. Now choose next 3 elements. Now Y is appearing 2 times out of 3, so Y will always be appearing in the mid, so W is also be converted to Y, because Y is also the median of these 3 elements. In this manner we can convert all the elements equals to Y. So I hope you are getting the point here. Now how to find the answer? Simple, very simple. What you have to do is just take all the elements in 3 pair. For example, first of all, let's suppose you have taken A, B, and C. Now sort A, B, and C, and whatever is the median, take maximum, or let's suppose answer is initialized with 0. Answer is initialized with 0. So first of all, take the first 3 elements. Okay, now start with the first 3 elements. Okay, first of all, let's choose first 3 elements and place place first 3 elements in the sorted order. Basically find the median of the first 3 elements. Okay, and whatever is the median, take the maximum out of the answer and the median. Let's suppose median is B, median is 2, let's suppose median is 2, and answer is 0. So what we can say? I can make all elements equals to 2. So 2 can be my answer. Okay, 2 can be my answer. Now I will move the window to the next three elements, B, C and W. And whatever is the median of B, C and W, I will take the maximum out of both. Similarly, we will place the we will shift the window by 1 at a time. Okay, and we will find the maximum out of all the medians of 3 size window. That's all about this. I hope you are getting the point. Okay, let me show you the code for this. Code is also very simple, guys. See, what I have done is, let me zoom it. What I have done is, I have taken n and array as input, and after that I am initializing my answer as 0. And if the size of the array is 2, means we are not having 3 elements. So just print the minimum out of both the 2 elements. Okay, because the minimum one will be the on the left hand side. Why the minimum we are printing? Let me explain that also. Let's suppose there are only 2 elements, 2 and 3, or also let's suppose 3 and 2 is the given order. So what is median? Median is the mid element after sorting the elements 2 and 3. Okay, 2 and 3. And what is going to be the mid element? If there are 2 elements, then we choose n plus n by 2, means 2 by 2, that is 1, means the first element is going to be my median. Okay, so as you can see that minimum out of both will be my answer if there are only 2 elements. So this is what I have done here. After that, what I am doing is I am running a window, you can say, of 3 elements. First of all, what I am doing is I am starting from 1 and I am going till n minus 1. Why so? Let me explain that. I am starting from the first index, okay, this end, and at a time I am placing this element I minus 1 and I plus 1. These 3 elements I am placing in a temporary vector. I am sorting these 3 elements and I am finding the median. And whatever is the median of the window that I'm currently working on, I will take the maximum out of all the windows. Okay, I hope you are getting the point. So what I'm doing is I'm taking a temporary vector in which I'm storing array of I minus 1 and I plus 1, means 3 consecutive elements at a time. After that, I'm sorting my given temporary. After that, I'm sorting my temporary vector in which I have stored the consecutive 3 elements. Okay, and what is the median of these 3 elements? First element, because 0, 1 and 2 will be the indices of the 3 elements which I am storing in the temporary vector, and mid one will be temp of 1. So I'm taking maximum out of all the windows, out of all the medians of 3 size window, and eventually we'll be ending up having an answer which is representing that after performing some operation number of times, we are having an array in which all elements are equal, and the element to which all elements are equal is maximum possible. That is represented by answer. So yeah, this is all about problem A, B and C, guys. I hope you have learned something from this. I will make a editorial on problem D also. Problem D is quite interesting. Okay, so stay tuned, like the video, and happy coding.